So, try number 3 here. I'm going to try to make a matrix of the absorbances and extinction coefficients for the standards, right? And so we'll look at acetone, toluene, and ethyl acetate at 290, 270, and 230 nanometers, right? So 290 nanometers, right? Let's come on over here and let's look down here for 290 nanometers. And that is row 113, right? So acetone, that standard, that's going to be equal to B113, right? And toluene, that's going to be equal to D113, and this is going to equal C113, right? Now to go to 270, that'll be a little bit farther down. 270 is going to be 133, right? So this will equal B133, equal B133. Toluene is going to equal B133, and ethyl acetate will equal C133, right? And then at 230, that is going to come down here to 173. Right, so this is going to be equal to B173 D173 and C173. Okay. So these are all of the absorbances, and I'll just get them under control there. And now what we're going to need next is some extinction coefficients for these guys, right? These are standard absorbances. I'm just going to make this guy a little bit smaller here. These are standard absorbances. Right, and then the extinction coefficients, this will, for acetone, it'll look the same as this, right? Except for the contents here will be different, right? And acetone, we will have, that will equal this divided by this. This will equal this divided by this. And this will equal this divided by this. And then toluene, that will equal this divided by this. If I just put the dollar signs there, and I can pull this down safely, I believe, right? And this guy will equal this divided by this, and we'll put some dollar signs here. Pull that down, Get these sig figs under control. And this is no longer absorbances, this is extinction coefficients. And this is percent, reciprocal percent, right? So, now the concentration of acetone, right, we're going to get from the 290 nanometer data, right? And that's where there's very little interference from toluene and ethyl acetate, less than, maybe 3%, right? So this will equal, so we need the sample absorbances here too, right? So we'll have the sample absorbances, right? And we'll make them 290, 270, and 230, right? And then, oops, move these down. This is going to be, oh no, this, I don't need to, this is just going to be those three values, right? So at 290, let's see, that's 113. So that is going to equal E113. This will equal E133. And this guy will equal, let's see, what value with this guy? Oops. This guy is going to be E173. Okay. So let's see here now. I'll get those guys a little more normalized there. And so now we have all this information. We have extinction coefficients and absorbances for the sample and the standards. So let's see what we can do about the acetone concentration here. So what I'm going to do here is I'm going to take this stuff, I'm going to move it down a couple of clicks here. And so let's take this formula here and let's solve it for acetone. Right, so in this case, C acetone will equal, come on you, not all of you, just you. Okay, divided by A300. I've got to get my equation editor here. A300 Oh dear God. Anyway, no, go away. So concentration of acetone will equal to epsilon of acetone at 300 times B over A 300, right? And C acetone will equal, and I'll right justify that, and we'll say, oh god, no, that's not right. What the fuck? It's A over epsilon B, right? God damn it. Stupid thing. Let's go the fuck away. This is tedious, sorry. So you just insert an equation. There we go. Script. C acetone equals, oops, no, got to get out of there, equals A 300, right? A 300 divided by epsilon 300. Let's see here. Epsilon 300 acetone. And then we'll put B in there, right? That will be in the denominator, right? So this guy here will equal the Stanford absorbance at 1.07 divided by epsilon acetone at 300 or 290, let's say. Right, and this is 0.00825, and this is roughly the amount by which this is smaller than this, right? If this guy's 0.01, then this is 00825, so that makes sense. So this is our first row calculation. So we can give this a calculation cell style, right? And then for toluene, we're going to have to use 270, I said 268 down here, right? But let's just take a look at this for a moment. That the absorbance at 268 for the mixture, right? It will be the acetone absorbance times concentration, or acetone extinction times concentration of acetone, plus epsilon extinction times concentration of toluene. This is all assuming B is 1, right? And so this is A equals epsilon BC plus epsilon BC plus epsilon BC, da da da, for all the components. And this here assumes that at this wavelength here, 268, whatever we're using, that the ethyl acetate does not contribute, right? So it's above 260, so that's pretty much a flat line there. So we're going to say that C dot toluene equals, right? And this will equal, now let's see, we're going to get A268 for the mixture, right? It's that guy, 270, right? Minus epsilon for acetone, C acetone, right? So this is going to be epsilon acetone at 268 times concentration of acetone, right? Okay, so that's going to be the correction to the absorbance. Let's just make sure that's positive, right? Okay, that's good. That's positive, right? Then we're going to take that and divide that by epsilon for toluene there, and that should give us the concentration of toluene. And that is a reasonable value, right? 0042. Whew. Because the standard here was this guy here was 005, and then saying that in this mixture it's 0042, which makes sense since it's on top of this acetone here, right? That is our second calculated value. There we go. And then 6 here is we're going to get the ethyl acetate concentration. Oops. That's going to be 4 right here. Right. Okay, so this is going to be 4. Right. And so actually we don't need this here anymore, do we? Right. So we're just going to have, because that's all up there. Delete, shift cells up. Okay. So now what we're going to have there is we'll have this equation again. But now we're going to use a different wavelength, and we're going to have ethyl acetate, right? So this is going to be 230. And then we're just going to have the same thing. But this is going to be ethyl acetate. EA, I'll just call it EA. Right? And so then we're trying to solve for CEA here, right? And so that'll be this minus this divided by this. So whoops. There we go. I'm not sure why it does that. So I'm just going to say CEA equals A230, right? It's going to be a script, a subscript, A230 divided by, oops, no, not in the sub, divided by not like that. Okay, well, I can cut you all out and put you in there. It's going to be A230 minus divided by that. I'm pretty sure that's correct. So let's just double check me here. It's concentration of ethyl acetate. It's going to be absorbance minus all that divided by that. Yep, that makes sense. So let me just see here. So right, justify that. And so this will equal, I'm going to left paren here. So I got to group all that stuff in the numerator. And I'm going to get the sample absorbance there, right? Minus epsilon acetone C acetone, right? So epsilon acetone at 230 times C acetone. And then it's going to be minus epsilon toluene times C toluene, right? Divided by epsilon for ethyl acetate. There we go. There we go. That's how we do that. And I got to make a correction of the formula there, obviously, because this has to be minus. But that is it. So this is how we get this is the most difficult way of doing it. And this is the selective elimination, or the sort of the algebraic method.